Okay, so let's go. Grüezi miteinander. Welcome everyone to the GRR Meetup in March 2017. This is from Zurich, as you might have heard already. My name is Andy. I am here today with a bunch of GRR developers. I brought Misha and Ben and Milos and our intern Letitia, who are also going to say a bit about the work that they do on GRR. So let's start with this. So for those of you who haven't been to any of our meetups, this is how it's going to work. We're going to make a small presentation, like 15, 20 minutes, not more than that, about the project, what we do, what the plans for the future are, what the changes are. And afterwards, we're just going to have a Q&A session where you can ask questions about GRR, how to deploy it, how to scale it, or about the changes that we have. There is a GitHub chat that Greg sent out in the announcement email for this event. So if you have any questions or want to interact with us, please log into that GitHub chat. This is what we're going to look at during the presentation and afterwards in the Q&A session. So the agenda for today. So first, Ben is going to talk a bit about Fleetspeak, which is the new client communication library that we have for GRR. Then we're going to talk a bit about our plans to move the GRR client to Go. We're going to have a little introduction of a new API client library that Misha wrote. He's going to do that himself. And then I'm going to give a bit of an update on the components that we use in GRR, about the memory analysis, the changes there. And last but not least, we're going to have a little update on the Datastore Options available to open source users. And then we will do the Q&A. So we'll jump right in. I'm going to hand over to Ben, who is going to do the part about Fleetspeak.
All right, so the basic idea behind Fleetspeak is to separate out the GRR communications layer into a separate library and a separate process. And there's a couple reasons for this. One is to make it possible for this communications layer to be used by other agents. That's sort of forward thinking, but the idea is that if people have some other desire for an agent that doesn't really fit into what GRR does, then they might find it straightforward to use this instead of coming up with yet another communications mechanism. The other point is that this isolation allows us to keep most of the GRR heavy lifting not actually running when we don't need it. So Fleetspeak will be a smaller process that runs all the time, and it starts up the rest of GRR when there is a request that the rest of GRR needs to handle. So big picture, roughly speaking, is that it's going to fit between the GRR client and the GRR server. And it's going to be separate processes so that we have, as I said, the additional isolation, additional in terms of resources and in terms of monitoring. And in terms of the functionality it's going to provide, besides communications, the key thing is that it will provide the client identifiers and labels. So anything else that's done through Fleetspeak will be able to have a shared identity, and you can label the clients there. And that's how, for example, hunts will allow you to start things on clients chosen by these Fleetspeak labels. In addition, it's going to keep track of the history of the communications. So it'll have a sense in which you can say, an analyst can say after an event, what did we hear from the client around this period of time? What might have happened, and so on. In terms of how we decided to design it, we decided to write it in Go for a few reasons, but as a compiled language, we hope for higher performance, smaller footprint. So for communications library, we think that makes sense. Also, we like some of the, like for cryptography in particular, we like the interface of the Go libraries for these things, and think it's a very natural language to use for this sort of task. The Fleetspeak, the client and the server, will communicate with each other using HTTPS. This is a replacement, hopefully an upgrade from the sort of hand-rolled communications that we currently use over HTTP. And then within the client and the server domain, we plan for Fleetspeak to communicate with the GRR using gRPC, which is a fairly new RPC library that Google is releasing, layered on top of the Google stores. So that's the direction we're moving. If it's under development, you should see at least a beta version of it fairly soon. We'll see how it goes. And now I'm going to hand over to Milos, who's going to talk about moving the rest of the Go client or the rest of the GR client into Go.
Definitely. Thank you, Ben. So we're experimenting with a Golang version of the GR client. The hopes here are that we will have better performance thanks to Golang being a generally lower level language than Python. We'll have strong typing, and also we hope to overcome some deployment issues we had with Python and pip-installer. There is potential with Golang to cross-compile, so that also simplifies packaging and deployment. So that's still experimental. We're in alpha with this, but we expect some results in the next couple of months. All right, so now Misha is going to talk about the API.
Yeah, thank you, Milos. So the full rewrite of, like we recently finished a full rewrite of GR admin UI to be a single-page Angular application. And as a consequence of this, we now have an HTTP API that pretty much covers all the functionality of GR that is accessible through the admin UI. So the API is documented using the generated documentation. You can see the link in your admin UI consoles, like in the bottom right. Here there's an illustration, like where the link is and how the documentation kind of looks like. And the idea is that you can use HTTP API to effectively script and automate GR. To do this easier, we have developed a Python API library, which is a separate pip package called GR API client, which basically doesn't have a dependency on GR server and client, which makes it much more lightweight. You can find code and documentation with examples on GitHub. The link is in the presentation. The important point is that your Python API library is based on Python requests library. And so it makes it then very easy to support custom authentication methods. So requests library has a simple plugin-based system that allows developers to implement various authentication methods. And it also has, for example, OAuth and authentication already implemented. And we also ship interactive IPython-based API shell called GR API shell. It gets installed together with the pip package, and it allows for easy experiments with the API. So to give you a feeling of how the code using the API client library may look like here's this slide. So the idea is that we create a root API object, in this case with a default basic authentication. So we only have to provide it with a URL of the admin UI, and then it will talk to this. And in this example, we basically search for all the clients that match the query. Like in this case, it's hostsuspicious.corp.com. And then we create a dictionary where keys are client IDs and values is at the time when the client was last seen. And then we print this dictionary. So the idea is using the API library, it's easy to automate actions and, for example, schedule flows or hunts using cron, or implement any custom logic. Pretty much whatever you want to automate or script in the admin UI, like you can do through the API library and through the API. Yeah, thank you. And I'm giving the reins back to
me.
Andy.
Good. So the next thing we have is the components in GR. So for those of you who are not familiar with components, that is a mechanism that we have to push code live to GR clients. So one component, for example, is Rekall. So whenever you run a Rekall action, the first thing that happens is that the server sends to the client a bunch of Python code, basically Rekall. The client loads it up, and from that point on, you can run your Rekall actions. We have experimented with this now for quite a while. and we have to say it is kind of stable. It's working, but it's not stable enough for us. It's not working in 100% of the cases, and that is an issue for us. I think we want to hold ourselves to higher standards here. Another problem we have realized is that the components are not really client version independent. So when you have a client running one version and you update the component to the next version, they might actually be not able so the clients might not be able to load that component anymore. And this is kind of what we wanted to achieve, and we figured out that that is actually not the case. And the third thing is that the components are problematic for accountability. So we have to admit that internally people don't like it when we ship code randomly to clients. And I guess that in other enterprises where GRR might be deployed, it's probably the same. So given all those issues, we have decided that we will deprecate the components in the next client version. So what does that mean for you? In the short term, we will build Rekall and chipsec. That's the two components that we mainly use at this point. We will build those components into the client, so you can just use them right away without shipping the code from the server first. The disadvantages here are mainly that you can't fix bugs in the component and push an updated version, but I don't expect many people to have done that anyways, and I also hope that not too many people have built their own component. Long term, we are probably moving to a system where we have standalone packages for all those systems that are now components. So we will have packages that get installed by the package managers on the machine or by Fleetspeak when Fleetspeak is integrated into GRR. And then GRR basically just shells out to those standalone binaries. That gives us a much better isolation. It will work much better, we hope, be much more reliable. So that's the story on components. The next thing, wrong computer. The next thing I wanted to talk about is the memory analysis part in GRR. So the team has to regret that Michael Cohen is moving to a different team inside of Google. So for those of you who don't know, Michael Cohen is our memory forensics guy. He is the one who wrote and maintains Rekall and the GRR integration of Rekall itself. So that is, of course, a problem for us. Because when Michael was working in my team, he was maintaining Rekall full-time, so 100% of the time. And at this point, he's going to do something else, and he's going to treat Rekall as his 20% project and probably as his weekend and night project. But the effort that we can put into Rekall at this point is a lot less than it was before. So what does that mean for Rekall in GRR? For now, we decided that we want to keep the Windows support alive. So we are going to actively try to maintain the Windows memory analysis part in GRR. But for Linux, at this point, it's a best effort from us. So it works currently, the Linux memory analysis, but the kernels will change and there will be reverse engineering needed to make it work again. And we probably won't have the resources to allocate to this problem. So it might break in the future. For macOS, the situation is even a bit worse. I think the recent kernels that came out are not fully supported by Rekall anymore anyways. And given the situation as it is, there's probably not much that will change about this. If you really need this, we always accept patches to Rekall to make it work again. Long term, we will see how Rekall develops, if it's still worth having it. But in the end, what we're going to support at least is to get memory snapshots from the machines. So in that case, you can't do funny things anymore, like getting a process list for memory from your whole fleet, because that's going to be prohibitively expensive. But you can still pull individual memory images and analyze them offline. So that will be a workaround. Okay, so much for memory analysis. The next thing I want to talk about briefly is the Datastore options that we have. The GRR data model we have is a bit tailored towards Bigtable, which we use internally, and that is not optimal for every SQL-based data store. And since we only provide for the open source version the MySQL and the SQLite data store, they're both SQL-based, that limits scalability, and this is something we want to address. So what we're working on is a completely new data model that will use Spanner. Spanner is an internal data store at Google that is SQL-based. And you can actually look at it. It was released for cloud customers. You can get a Cloud Spanner instance and just store data there. And that new data model will be SQL-based. So it will be very easy, and we hope it will be much better compatible with MySQL and SQLite. So we expect huge performance gains there. But we will see. This is just work in progress that we just started. Okay, and with this, I think we are done with the presentation part. So at this point, we will take questions if you have any. So the first question I have here on YouTube is GRR capable of running GRR via Rekall? Yes, GRR is capable of running GRR via Rekall. It can do both. It can scan memory. It can scan binaries. Basically, whatever Rekall supports, GRR supports too. So GRR just passes every parameter that you send into it directly to Rekall. Whatever Rekall supports, you can run via GRR. I think that's the straightforward answer. Then people want to know about the Golang-based GRR client and if we have a timeline for that.
Well, I guess it's going to happen in the next couple of months. I'm not able to say more precisely that there are still many unknowns. We're exploring the area.
Yeah. So a bit more about the Go client. I think this is an experiment at this point, right? So we are implementing the client first because the client has very few dependencies, unlike the server that needs a lot of libraries to be ported first. And we're going to see how the client works. If the client is very little effort, which may happen, but maybe not, then we will speed up and we'll probably just convert the whole project. But I don't want to make any promises on that. So, the timeline is really far out. I think this will take quarters, but we'll keep you up to date. What we have been working on now is a directory structure so we can export it to GitHub. And once we have done it, you can actually see the progress yourself on GitHub. I think that should hit soonish, right?
Soonish, exactly. Yeah, we also hope that it will be easy to integrate the Go client with Fleetspeak, as it's also going to be written in Go.
So we need a couple of things for that. Does anyone know Nginx for HA? Is that the best way? Do we have any more questions? No, Nginx now. Kejan, we saw your question, but we don't know what HA means.
Well, it's probably high availability, but I'm not sure how a reverse proxy helps us be.
So,
I mean,
for load balancing, yes. So, the issue is not with that. So basically, what happens is you can scale up by having multiple front-end servers. So you can set up 25. That's fine, and then you can handle clients easily, as many as you want, probably. But all those 25 data front-end servers will hit the same database, and this is where the bottleneck is at the moment. Because once you get to like reasonable amounts of data in there, then it will slow down, and this is what we're addressing. So yes, Nginx as a load balancer, that makes a lot of sense. But what we're trying to speed up here is the backend and not the front end. Any further questions? Going once, going twice. Okay, well, I mean, if no one has any questions, then I would say if you later find out that you do, please hit us up on the GRR Users mailing list. And thank you all for joining. Oh, let me do this. SQLite plus HTTP data store. Probably yes. So the question is if we want to support the SQLite plus HTTP data store. So the new data model will be very easy to adapt to new storage systems like the SQLite one. So there is very little reason to deprecate it. I think we will have to look first how the MySQL data store scales. If it scales very, very well, and there is absolutely no reason to use the SQLite data store, then we might decide that it's not worth the effort. But even if we do, it should be very little effort to do it yourself. So I have actually worked with someone who implemented that approach, the one that we have for the MySQL data store, and it took him like a day or two to just convert everything, and he got a speed up on the tests for like 50%. So for now, I think it's going to stick around. If we actually want to deprecate it, then there's going to be a good reason for it. So there will be a better replacement. The other question is, when will the API client lib be released?
It's already released, and basically the pip package is already available, and it's on GitHub. Basically, it's located in the same repository as GRR. So if you go to API_client/Python, you will see it there, and there are docs and examples. So it's already available and ready for use. So the only caveat is that so the HTTP API itself, it is 100% complete, and it covers all the functionality of admin UI. The API client library covers most of the basic use cases that we ourselves use. But some of the HTTP API is not covered by the library. So we plan to extend it and basically plan to make the library cover the whole of the 100% of the API pretty soon.
Okay. So the next thing is, next question is the timeline for the Spanner support. So it's unclear. I would tell you about the current status. So I have code internally that uses Spanner, and it's just the proof of concept. So what we're going to do, let me quickly go a bit into the details. So at the moment, we store everything in AFF4, which is the forensics format, and we store the forensics data in there, and we store the metadata in there. Forensics data should be there, metadata should not. It's a very bad format to store metadata, and this is what we want to pull out. So I have written proof of concept code that stores some parts of the metadata in Spanner, and that works internally. And there is more work to do there, but that will probably not be too much. At the same time, we have an implementation for the MySQL data store that does the same thing. It pulls out the metadata, but it lets the AFF4 data still in AFF4, so it has to support both, which is not great. And we're not sure how quickly we want to, or how quickly we can fix that. But once we get that done, we can give you at least an experimental data store that will be faster and that you can use for testing. 100% conversion will take a while, I expect. But we'll keep you updated on this. Good. Any more questions? Wait 30 seconds until it reaches down. Well, great. In that case, as I said before, if you have further questions, please hit up the GRR Users mailing list. And thanks everyone for listening and joining up today.